we'll be doing an analysis regarding a food database provided by Corgis. Here you can see the data structure for our food database is broken down into four larger categories: category, data, description, and nutrient data bank number. Under data, you can see the largest number of elements provided beneath. Each data set is a single macronutrient, and there are four larger subcategories: vitamins, fat, and major minerals that each have their own subcategories, and household weights used to describe the weight and the measurement of each of these micronutrients. So to start off this project, we're going to look at what an abstraction is. By definition, an abstraction is a reduced representation utilized to represent a real-world entity to garner a foundational understanding. In this specific project, the real-world phenomena is macronutrients, and the two specific elements that we're going to be looking at are proteins and calcium. While looking at these macronutrients, protein and calcium, we will look at the presence in foods and make comparisons between these states. So before we go into an interpretation of this food database, we must look at the limitations provided in this analysis. First of all, only a fraction of all foods available are present in this data set. This is due to the simple fact that all foods cannot simply be represented. It's not feasible and entirely up to interpretation what may or may not be considered food, what is allowed and not allowed to be in this database, what can be measured, and more. Furthermore, full meals are difficult to analyze. Within this database, only certain foods are explained in isolation. Therefore, we do not know the combination of foods being put together, the chemical reactions that happen when food is being cooked, and all of the ingredients that are being used in a full meal. Doing so would require tedious calculations and a significant analysis. In addition, there is broad labeling within these limitations in how food is described. For example, categories such as food dressing, baby food, Popeyes, and ice cream could each have their further subcategories. However, only one instance of each of these labels is provided. Ice cream, for example, ranges from chocolate, vanilla, and strawberry, and more, and can each have their own varying macronutrients associated with it. So the first question we're going to look at is how much protein is in one serving size of beef. In the data provided, you can see that, my apologies. In the data provided, we can see that we were looking at specifically beef within the category of the data structure. And within that, we were looking at exactly 28.35 grams of beef. The reason we chose this number is the dataset uses this specific number or this specific unit of measurement to determine what a serving size is. Using this, we plot a histogram to determine how much protein is in each amount of beef. The protein is measured in grams, and we can see from this visualization that most servings of beef have between 23 grams and 31 grams of protein. A further conclusion is to deduce that beef is a protein-rich food. In our next question, we want to determine if there's a correlation between protein and calcium in foods. The reason we're curious about this is one might assume that calcium and protein are highly present in meats. So to do this, we create a list of proteins and calcium, and we append the data with their respective macronutrients. We use a scatter plot to determine if there's a correlation between protein and calcium in foods. And one problem that we have within this data set is that there is an extreme located in both of these elements. For example, it is not feasibly possible or logical to assume that there are any foods that you can eat or are feasibly available that have over 3,000 grams of calcium and over 80 grams of protein. It is not typical within a traditional diet, and therefore we should not fully utilize this data because it's not relevant to what we consume day to day. So because of these large extremes, we cannot fully determine a correlation. However, if we would like to determine a correlation, we can eliminate these extremes. And what we did was we eliminated the top 10% of data in each calcium and protein to determine if there is a new correlation within the more relevant foods provided. Here we can see that there is actually a somewhat positive correlation between calcium and protein in a y equals x sort of variation to determine the correlation. It's still somewhat unreasonable to assume that there can be over 2,000 grams of calcium reasonably available in food. However, to be fair to our data and have a fair interpretation, an even amount of calcium must be eliminated with respect to protein to determine a correlation. If we ignore the extremes in the top left corner, we can see there's a positive correlation between 0 and 40 grams of protein and 0 and 1,000 grams of calcium. Social impact. So now we're going to analyze why this information is important and who it is important to. It is important to consumers or every individual looking to optimize their dietary habits and proactively live a healthy lifestyle. If an individual is able to confidently determine what food is and is not healthy for them and determine which nutrients they need and what food it is present in, they will be able to live a much more healthy lifestyle proactively and do so independently. This information is also relevant for dietitians providing advice to their clients. Their clients can range anywhere from individuals struggling with obesity, individuals struggling with health complications, such as people with diabetes who need to limit their sugar intake, and athletes who do not have a different set of dietary restrictions because they are looking to improve performance and can have very specific, very protein-rich foods. Finally, the last category of individuals included in this social impact is healthcare providers. They need to understand dietary habits, and they come in two forms in this presentation. Hospitals use this to assess the current health of their patient and correct their diet and see if the reason that they are matriculated into a hospital has anything to do with dietary concerns. And furthermore, insurance providers can adjust their rates based on the health of their clients. So individuals who are more susceptible to having heart issues or any other bodily complications due to their poor dietary habits will be at risk of having higher rates. Finally, this is the honor code for my slide, though not necessarily required in this presentation. I've written off that I have neither given nor received unauthorized assistance on this assignment, and that has been completed totally and entirely independent by myself. Thank you.